Hi everyone, me again, and we're back with section 3 of your factoring notes, which is factoring perfect square trinomials. Okay, now I'll be honest with you, on these, a lot of the time, I don't necessarily treat them as a special type of problem because I don't always recognize them as that. Okay, a lot of the times I just approach them like this one. I would probably go with my trick that I taught you yesterday. 9 times 1 is 9, look for your combination that makes 6, break it apart, do your grouping, all that stuff. And then just in your answer, you're going to notice something kind of cool that comes up. Maybe not cool, but um, something sort of unique, okay? So if you don't recognize these as like perfect square trinomials, it's okay. But let's talk about what I mean by a perfect square trinomial. So perfect square trinomials come from squaring some sort of binomial. So let's say I take a plus b and square it, okay? We all know that that means I'm going to have to do a plus b times a plus b. We did this just a couple of days ago when we did binomial expansion. You could do this even with Pascal's triangle if you wanted to. But bottom line is this is going to come out to be a squared plus 2ab plus b squared, okay? So the idea here is that if you look at one of these problems and recognize that it's in this form, you can jump immediately back to this setup for your factoring, okay? Two identical factors, all right? So let's talk about what this form really looks like. Honestly, I think the biggest things you're going to catch are that you have perfect squares here and here. Okay, perfect squares on the two ends. That's kind of the first thing I would look for. That's my red flag. But then you need to make sure that this works out as well, okay? And so where that really comes from is if you took the square root of this and the square root of this and multiplied them together and had two of them, right? Because if we did FOIL, we know we would get two copies of the same thing. So square root of this, multiply them together, and then multiply by 2. That doesn't always jump off the page at you, but let me show you what I'm talking about. So looking at this first one, I recognize this is a perfect square and this is a perfect square, right? 9x squared, 1, both those perfect squares, okay? So if I was to square root this, or if I was to split this into two pieces, it would be 3x, right? And if I was to split this into two pieces, it would be a 1. So then the question is, does this equal 2 times 3x times 1? And it does, okay? So this right here is a perfect square trinomial. And so if you think about this right here, again, if you recognize that and you know these two pieces, then we should be able to just say this is 3x plus 1 times 3x plus 1. Okay, and again, those two things came from this up here. Okay, a lot of arrows today. Okay, but again, if you didn't catch that, if you didn't look at that and go, oh, hey, that's a perfect square trinomial, you could always do this the same way we've done all our other factoring, okay, and it would work out just fine, okay? This is supposed to be a shortcut, but it's only a shortcut if you recognize it, okay? So again, with this next one in my brain, I would be noticing that this and this are perfect squares. This would be a 10x, right? And this would be an 8y. And then the question is this thing in the middle equal to 2 times 10x times 8y? Okay, does that work out? Well, 10 times 8 is 80, times 2 gives you 160, and then x and y give you the xy. The one thing that's a little bit different here is that we have a negative, okay? So one of these two things must be negative. And remember, when you take a square root, technically it could be positive or negative in order for this to work out. Typically, we would just make the second one negative because that just lets you write it as subtraction. But you could probably get away with making the first one negative too. It would really come out the same, okay? So that means that because this setup works for me, and I have 10x and negative 8y, I could write this as 10x minus 8y and 10x minus 8y. So in this setup, you are going to have two of the exact same factors, right? But because you're not trying to cancel out the thing in the middle. And if you factor, or if you foiled this, I'm sorry, 10x times 10x, 100x squared, and then you would get negative 80y and negative 80xy and negative 80xy, which gives you negative 160xy. And then you would get negative 8y times negative 8y, positive 64y squared. Okay? So again, this one is all about recognition. I personally find these harder to recognize. Okay, some of them, jump off the page at you a little bit more than others. But I would say anytime you've got perfect squares on the two ends, that might not be a bad thing to check, just to save yourself the trouble of having to do any other type of factoring first. Okay? Okay, so your homework for tonight is just page 2 of your factoring packet. And I do want you doing all of them on page 2. Okay? One side of the page is the difference of two squares, and one side of the page is this, the perfect square trinomials. I don't remember which is which, but see if you can knock out page 2 today, and then tomorrow we'll go over all those pages you've done so far and start doing some mixed review. Okay? Have a good one.